Hi everyone. Okay, pre-calculus 1.5, pattern functions and transformations. Okay, all of this is a review from Algebra 1 and Algebra 2. Okay, so we'll cover those concepts here. Pattern function. So when you deal with the graph of the function, you need to know several kinds of pattern function, top of your head. So there's a constant function, so such as y equal to 2, then you should have a horizontal line. Y equal to x is a linear function, just straight up, right upper corner, like that. Y equal to x squared, well, y equal to x, so if you go 1 to the right, so value of x becomes 1, you can easily plug it in 1, y value becomes 1. So here, you can have 1, 1. If you go to the right by 1 for value of x, y value is 1. So y equal to x squared, same thing. It's a parabola open upward. If you plug in x, so here, 0, if you plug in x equal to 0, y is 0. If you plug in x equal to 1, 1 squared becomes 1, so y value is also 1. So couple points left and right, you do want to be very familiar with it. If you plug in x equal to 2, 2 squared will make a 4. Okay. So same thing to the left hand side. If you plug in x equal to minus 1 here, minus 1 square parenthesis square will make 1. So minus 1 will be 1. Minus 2 if you plug in, it will become 4. So this one, you should be able to roughly sketch it without using graphing calculator, without referring anything. So this one too. If you plug it in 0, 0, if you plug in 0 for x, 0 cubic makes a 0 for y. So 0, 0. If you plug it in 1 for x, 1 cubic is still 1. If you go minus side, if you plug it in minus 1 for value of x, minus 1 parenthesis cubic will make minus 1. So y value will be minus 1. Okay, all these, you should be able to sketch it without graphing calculator fairly quickly. Basically, you need to memorize it. Y equal to square root of x. If you're not familiar with this, we'll get to know this graph. It's very simple. If you plug in x equal to 0, square root of 0 is 0, so y value becomes 0. So you got 0, 0. If you plug it in 1 for value of x, square root of 1 is 1. Okay? Then it's going to be some decimal if you plug it in 4 for value of x. Square root of 4 makes 2. Okay? So the graph looks like this. What happened to the minus side? If you plug it in value of x as a minus, it's undefined. It's imaginary number. So nothing's here, just to the right side. Okay, so rational function 1 of x, it looks like something like this. Again, simple point. If you plug it in 0, it's going to be undefined. There's nothing at x equal to 0 because 1 over 0, denominator becomes 0. If you plug in x equal to 1, 1 over 1 becomes 1. That's why they have a 1, 1 right here. If you plug it in minus 1 for value of x, 1 over minus 1 makes minus 1. So that's why they have a minus 1 as a coordinate. So if you have a 1 coordinate here, another coordinate here, that's how you roughly sketch it. Absolute value of x look like a V shape. So if you plug it in 0 for x, absolute value of 0 is 0, so y value will be 0. If you plug in x value as 1, absolute value 1 is 1. So you get 1 to the right, 1 to the up. If you plug in x value as a minus 1, absolute value minus 1 becomes a positive 1. So you got left 1, up 1. So you have a V shape, excuse me, V-shaped graph. Greater integer function. It notation like this. It's not that popular. I mean, you hardly see something like this, but from time to time you might be able to see it. What's the definition? Greatest integer less than or equal to x. So if you think about here, let's say trying to put value of 1. If you put value of 1, question is, what's the greatest integer less than equal to 1? Greatest integer less than equal to 1. 1. So that is 1. So you get 1 here. So that's why when you have 1, you got 1 here. What if I ask you 1.1? So if I ask you what's 1.1, this notation. So greatest integer less than or equal to 1.1. 1. You cannot go 2. 2 is more than this. Okay? Less than equal to 1.1. So it should be still 1. What if I ask you 1.5? 1.5 greatest integer less than or equal to 1.5 should be still 1. 1.6, 1. 1.7, 1. 1.9999, still 1. Only if you become 2, I can ask you, what's the greatest integer less than equal to 2? Then it becomes 2. So look at this graph. 1, x equal to 1, y value is 1. X equal to 1.1, y equal to 1. X equal to 1.5, y equal to 1. X equal to 1.9, still y is 1. As soon as x value becomes 2, y value becomes 2. So it looks like a stair. This is a stair function. Okay? So this one is not that popular, but since it's here, I just explained to you. Okay, describe the following characteristics of the graph of the parent function, 1 of x. Domain, range, intercept, symmetry, continuity, and the behavior intervals on which the graph is increasing, decreasing. Okay, so with this, it's very possible I ask you this question without graphing calculator. Then you should know basic graph of the graph. I just went over it. So if you can graph, like I know 1, 1 minus 1. So if you can sketch something like this without graphing calculator, then you are in very good shape. If I let you use graphing calculator, well, then just put that into the graphing calculator. Type that thing into the graphing calculator, you have graph in front of you, okay? Then you start answering those questions. So the question was asking all this. So let me just go over these together. So given graph like that, domain means all possible x value. So you're looking at the graph, how far to the left the graph reaches. Do you see this arrow here? It keeps going to the left forever. It covers everywhere. It covers everywhere. It covers everywhere to the right, except right here. At x equal to 0, there's nothing there. It's not defined. So domain is covering everywhere but x equal to 0. So how am I going to answer this? X cannot equal to 0. Done. That's the answer. Okay, for Alex, if you're using some kind of software, Delta Math or Alex, you may not have this choice. They might ask you, write that as interval notation. Then you will have to do on a number line, such as number line here, and 0 is not included. So you can cover all the way to the left. You can cover all the way to the right, but 0 is empty. How do you express that? Minus infinity to 0. Most left to right. Minus infinity to 0. Union with 0 through infinity. So that's interval notation way. So if this formation is available, you're done for the domain. If they ask you, you need to write that as an interval notation, then this will be the answer for domain. Range means how low the graph covers to how high the graph covers. So how low, as you can see, it keeps going to the bottom, keeps going to the top, covers everywhere except right here. Y equal to 0, there is nothing there. So same thing, you can say y is not equal to 0. If they ask you interval notation, you have to do the same thing. Minus infinity to 0, 0 through infinity. Okay? Interval notation will be exactly same style if you have to answer in interval notation. X-intercept means where is the graph hitting the x-axis? Where is it crossing x-axis? Nowhere. Doesn't even touch it. So just not available, none. Just leave it blank. Y-intercept, same thing. It's not touching y-axis. None. Just leave it blank. Symmetry. Okay, so that's from last chapter. Symmetry, there are three kinds of symmetry here. Symmetry of x-axis, can you flip and matches on the bottom? No, it's not gonna work. Symmetry of y-axis, can you flip? No, it's not gonna work. Symmetry of origin, this part, top right corner, can you reflect it and reflect over x-axis? Yes. It is a symmetry of origin. So respect to over symmetry over origin. Continuity. You can tell. It's continuous everywhere but here. It's discontinuous at x equal to 0. So discontinuous, what kind of discontinuity? This is infinite discontinuity. So you can say infinite discontinuity, et at x equal to 0. Infinite discontinuity at x equal to 0. And the behavior. Okay, as you go to the left, what happened to the y? It approaches to 0. Okay, as you go to the right, what happened to the y? It approaches to 0. Okay, so if you remember that my shortcut, you compare power of x numerator denominator. Power of x on the bottom is the first power. Numerator doesn't have x, that means x is 0 power. So we have a higher power on denominator, then you will have horizontal asymptote as 0, meaning end behavior will be always 0. Okay, so what you say is right end. If you go right end, if you go to the right, it approach y approach to 0. Okay. If you go to the left, y approach to the 0. So be careful how you can express this notation. So algebra 2, we learned that as x approach to infinity, f of x approach to 0. As x approach to minus infinity, f of x approach to 0. That's how we did in algebra 2. Okay, pre-calculus, I need you to be able to do this using limit notation, which is the limit of f of x as x approaches to infinity is equal to 0. That's this statement. Limit of f of x as x approaches to minus infinity approach to 0. That's this part. Increasing and decreasing. So okay, so as you move to the right, what happens to the y? Decreases. So where to where is it decreasing? Minus infinity to 0. minus infinity to 0, decreasing. Then as you move to the right, it decreases again here. Where to where? 0 through infinity. 0 through infinity. Where is it increasing? Nowhere. That's nothing there. Okay, given this, analysis was this. We answered all the questions there. Okay. Translation. Another word, shifting. There are vertical translation, horizontal translation. So I'm going to post this PDF file to Canvas, so you can print it out. You can have it with yourself. So adding or subtracting to equation is related with the shifting translation. So vertical translation is either moving graph up or down. So if you look at this example, this is a original graph. Vertical, if you move vertical to shift up by certain value, you're going up by this. Down, then you go down by this. Okay. If you're moving to the right, the original graph, you move to the right. Original graph, if you move to the left, we shift to the left. How do you tell? I usually explain in a way, it's all about x. If x can see the number added or subtracted, it's about vertical shift. If x can see the number added or subtracted, that's shifting in terms of x. If x can see it, it has something to do with x. This is x-axis. Horizontal axis is x-axis. So if x can see the number, it's either move to the right or move to the left. If x cannot see the number, it has nothing to do with x, meaning it has a thing to do with the y-axis, moving up or down. So when I say x can see, x cannot see, you might say, what do you mean by that? So for example, let's say original equation is x squared. If you have x squared plus 3, I am claiming x cannot see 3. Some of you say, why not? They are right next to each other. Because of the square. X is covered by square. X cannot see outside of the square. X cannot see 3. Well, if you look at here, x squared minus 3, I'm saying x cannot see minus 3 either because of the square. So I am saying plus 3 here, minus 3 here has nothing to do with x, meaning it has a thing to do with y. So since it's a plus 3, whatever this original graph, you move up by 3. If you have x squared minus 3, you move down by 3. Okay, some of you still might say, I don't still understand what you mean by x cannot see 3. Here's a horizontal shift here. So if you look at this guy, if you have an x plus 3 parentheses n squared like here, look at the structure, the difference of structure between this and this. This, x cannot see 3. This, yes, x can see 3 because they are under the square root together. X can see plus 3 there. So you need to be able to tell, okay, that's what he means by x cannot see 3. Yes, x can see 3. So if x can see 3 plus 3, that has a thing to do with x. You remember, x-axis is a horizontal axis. So what does that mean? We are going to move either to the right or move to the left. Horizontal is always a troublemaker. Horizontal is a weirdo. You just think like that. So what do I mean by that? Plus 3, you want to say it's plus 3, so plus direction in x-axis is right. So I'll say, yeah, we are moving to the right by 3. We are tempted to say that. Don't, because x is weirdo. You will move to the left by 3. Okay, just remember x is weirdo. So if you look at this, then you get to compare. X cannot see minus 3 here. X can see minus 3 here because they are together under the square. So X can see minus 3, it has a thing to do with X. Either we are moving to the right or left. You might say, where? Minus 3, you want to say to the left by 3. You remember, X is a weirdo. So horizontal shift, you gotta go opposite direction. So you gotta go right by 3. Okay? So like this. Graph the use the graph of this to graph a function of this. So of course you need to know original graph. That's why I explained the parent function in the beginning. You should know x cubic. You should know it looks something like this. Okay? One to the right, one up. One to the left, one down. 0, 0. You should know that. Then from there, you're looking at minus 2. So my question is, can x see minus 2? Answer should be no. Because of the cubic power, x cannot see anything outside of the cubic. X cannot see minus 2, so minus 2 has nothing to do with x. That means it has a thing to do with y. Y means move up or down. Minus 2, you're moving down by 2. So this is the x cubic minus 2. So you might say, well, I have a graphing calculator. Can I graph this original? Your calculator show it to you. Then can I graph at the second graph and I get to see what happened in the graphing calculator? Well, answer is yes. If I let you use a graphing calculator, you might be able to detect that kind of shifting using graphing calculator. But it's very possible if it was in-person learning, I would say no calculator, you do this without graphing calculator, then you need to know how to do algebraic code. Like this question. So this is a parent function. This is the transformed graph. I am asking what kind of transformation. So you see the difference is we have a minus 1 here. So you should question, okay, can x see minus 1? The answer should be yes, because they are under the cubic together. X can see minus 1. It has a thing to do with x, meaning either move to the right, move to the left. Minus 1, where do we go? X-axis, direction of minus is left. So you are tempted to say, yeah, you should go left by 1. Do you remember? X is weirdo. You gotta go opposite direction. You gotta go right by 1. So that's the that's original. That's a transformed graph. Okay, so if I show you this versus this, we have two transformations. So I'm asking, what is minus 1 doing here? X can see minus 1? Yes. So it has a thing to do with x. Should we go right by 1, left by 1? Right by 1. Minus 1, shouldn't you go to the left by 1? Do you remember x is a weirdo? Minus 1, you gotta go right by 1. Okay, minus 2. X can see minus 2? No. So you should go down by 2. So from here, you go right by 1, down by 2. So that's the point. You go right by 1, up by 1, left by 1, up by 1. That's how you do graph. Again, if you say, well, I'm going to graph this using calculator, I'm going to graph this using calculator, then I'm going to compare it, you might be able to get the answer using a calculator if calculator is available. Okay, so pause the video, please try. You're seeing the answer. You got this answer, that means you're in good shape.